Hey folks, thank you for joining me in this talk. I think we'll get started. All right, cool. So today's topic is pretty interesting. It's slightly off from the custom things that we anyway do for application development. It's a concept that is pretty popular. It's just not widely used across the industry, right? So this is a thing called page out of. It's just my experimentation with something called a server-driven UI or config-based UI. So we as engineers on the front end love to do a lot of UI work. I know I, for one, would love to do platform more than UI. But there's also a chance that there are a lot of servers, engineers, backend engineers that could really use that quick deployment, which Android has certain bottlenecks. So with that, a bit of, With that, a bit about me. I'm an Android GD. I'm Adit Lal. I'm basically an individual consultant. I work with a lot of clients. I'm currently working with a company called Misho, which is based out of India. You can find me on social media across these links. I also have a blog when I sometimes dabble on Android, right? So today's topic is very straightforward. It is all about, we're going to take a look at how code works. Obviously, I'll give you some snippets. Just remember, this is not production code. This is actually just giving you the concepts and why it's important to try this, right? So the first thing that we're going to look at is what do we expect from server-driven UI, right? Now, the idea is that I want to control the core UI. Like there are certain screens that my manager says, hey, let's bring this change, and we have like 2 days to develop it. Great, all that is fun. But when we go live, there's so much of added functionality that you need to take care of, and there's also the place to review times and so forth. So server-driven UI, the core idea is that I want to control how the UI looks, but without actually touching any of the code on Android. I would rather get some server config, like downstream through JSON protocol buffers, whatever your poison is. The idea is that the user should not even notice that something has changed without a Play Store update, right? And I want to control certain components. It's very useful for like A/B testing with what UI works. Like I've worked in a lot of industries, especially e-commerce, chat applications and whatnot. There are a lot of users who have a lot of different use cases, and they want to play around with that use case, correct? Now, when I talk about use cases, now the user doesn't care whether it's blue in color or it's fancier than the previous version. They care about data, and they care about what they expect, right? So I want to control some of those aspects. I want to play experiments with if a banner image is showing up or not. Do they actually click on it? And if it is not, I would want to turn it off for people who don't use it anymore, right? It kind of plays very well into feature flags. So if I want to test certain features on production, I can actually have a server config that tells me this is how I want it, and this is now different for me, right? So there could be like 50 users out of, say, a few hundred, and they could be using some brand new tech or brand new designs, and I want to play and get feedback very early on. You could do this on homepage, you could do it on like multiple screens, or you can build the entire apps from scratch, and it'll still be fun, right? Now, the best thing about this is you do it once, you reap the benefits over and over again, right? There are a lot of things that you could reuse from the server configs. Now, you must be wondering, all this is great, but what is the goal? The goal is very, very simple and very, very easy to achieve. The UI should be a breeze to change. It should not be something that, hey, we built this home screen a decade ago or 30 days ago, and there's new engineers on the team. Now, there's a cadence that you need to have. You need to have KD sessions. You need to have people that understand what components come together. It could be a recycler view. It could be some kind of a static content, but you want to control all of this. What I want to kind of change that aspect of that is that it should be a breeze to change without actually going through the hoops and loops of testing and whatnot, right? There's a lot of circles that you need to cross. Now, code should be very dynamic. In today's world, if you write a lot of static code, when I say static as a keyword, it's not the static keyword from Java, but it's more or less like you build your app once, but you want to also experiment with your users. You want to see what works best. Now, Play Store already has a lot of things you could do with your graphics. You could do it with your icons and whatnot. But the content inside your app actually matters. And if you can control that, that's what this particular goal is about. And building UI should be as a snap. I click one thing, and it should just work out of the box, correct? Now, as a team, if I can learn, adopt, and change few things without actually going through the same hoops and practices, that will be really amazing to go and do it just by a flick of, say, a server sending a different config for a different particular screen. And that's where the user really enjoys the app. Now you must be wondering, what's the problem today? Like, why are we even solving this problem, right? Like, what originated this? Now, today's world, we have like a service or an API, the blue box, nice and fancy, it's sitting on a cloud or some kind of a service. We take this data and then we send it downstream to the client, correct? Now, we could have 2 more services, 3, 4, whatever it is. If you realize that we are also building a lot of apps, there are a lot of like multi-split apps, or they could be enterprise edition apps that could have like multiple clients. Like I've worked for a microfinancing company which has like 6 apps, same server, but then the UI is like, again, repetitive. Even though we have like an in-house design system, but then the components were like getting reused a lot. And the server would send data in a different way, but it was still a painful task for the front end to keep doing that innovation. Now, this is where the problem originates. Now, you might be seeing a lot of spaghetti code, right? There's a lot of those services that even the client 1 also needs, the client 2 also needs, and so forth. Now, all of this is very front-end heavy. Now, if you want to control some bits, I'm not saying then write the entire app on server-driven UI, but then control some parts of your screen that could be, a bit of a config-based. Now, what are we trying to see from, all of this? The downsides of, doing front-end work. There's a lot of heavy, client-specific language or protocols you need to do to go through your UI, right? There are a lot of things that you could be writing recycler views, you could be doing a lot of adopters, text views, buttons, and whatnot, and these are very difficult to, again, iterate. So imagine this. There's a scenario where your users are complaining to you that, hey, the button is not clickable, or it's too close to the edges of the screen, and I can't do this. Imagine having a new version of this, 15.1 or something, and then you're shipping it to Play Store. The cycle is like very vicious, right? What if you could just flick one switch on server and the button moves a certain position, or it goes to a new design segment, right? Now, all of this can be achieved by server-driven, but it's not currently being able to be done on something written on the front end only. Now, there's a lot more to do if you have a lot more clients, like a lot more application that you need to develop from scratch, correct? Or you could be even building something in the legacy side of things, right? Now, this could lead to a lot of duplicate code. I myself, for one, have written so much UI in my time that I've come to realize that there are a lot of things that I could be doing the same thing over and over again for a different project in the same company, but a different, a new app that is probably just springing up, right? Delivery gets hard thanks to a lot of the protocols that we have to go through just to get the reviews, the testing, and the cycle is like pretty large that way. And building UI components from scratch, imagine as a PM or a product manager, someone says and comes up to you and says, hey, we are building this new feature. It has 5 screens, and you need to deliver this by next month, right? First week of that, and you have like 15, 20 days. It's great to do all that. There's data already available, server APIs are ready. You have to start working on UI. Now, all of that put together, 15 days is not enough. There are a lot of things that could go wrong. There's a business logic. There's a lot of like language syntax. There's linting. There's platform things you need to handle and so forth. What if I can ease some of it from the UI perspective and push it to another component layer? Or it could be a network layer, which then is controlled by server. So that is what we are trying to do, and that is what the change is. So what I'm proposing here is, again, this concept is not new. It's followed by a lot of people, Airbnb, Spotify. A lot of people do this, but write your code in such a way that it can render a state. So it's basically the concept of finite state machines. You have certain states that the UI would react to, and that would be the end destination. So instead of being very unpredictable with variable components on the UI side, you have states that govern what the UI would do, and that will be a controllable fashion. Very similarly, you should have events that could then change the state of a certain screen, and then that would react accordingly to the UI component. So the idea is that events and states are just, probably you've already written architectures that already have these components, and you're just reusing them, right? Now, what's the idea? Now, this has been stated multiple times in the past, but I'll still kind of say this in a very fancy way, right? UI is a function of state, right? A lot of you are like Kotlin developers. When you write functions, what do? You pass in variables, you get an input, you then process it, and you get an output out of it. It could be like an XML-driven thing, compose-driven thing, whatever you guys are fancy right now on UI. It's still a function of what you're trying to represent from a data point of view, right? An API returns your data, maybe a database, or whatever your data source is. You're taking the data and then drawing UI based on that data. I also have this small thing that I keep doing with my peers, that most of the Android apps are sort of like a read-only apps. Like we'd react to something that's happened on server, or there's some kind of a data source that is outside the ecosystem, and the app is then reacting to it, and there's some user inputs and so forth. So that's why I call this UI as a function of state, right? Now, how do we put this into motion? Like, what's gonna be the baseline for how to set this all up? The most simplest thing that I want to set up as a principle is that it should be easy to understand. It should not be something that it's like some engineer comes from building UI, but it's like, hey, what is this? Where's the configuration coming from? How do I test this? How do I mock all of this, right? Now, it should be very flexible for designers. I know a lot of designers in my past have been like, damn, we give you this and you're not built it this way, or this not pixel perfect. What if you could build these components? Think of it from a design system library of sorts. Like you have a component library which spits out components, and then you reuse them based on what the data is trying to tell you. So, and the designers could do it in a pre-phase. Like before even the feature goes out, the designer's already happy with it because the component behaves in a certain way. Very similarly, you don't even have to launch the Play Store or the Play Console. I, for one, I only go there for like A&R reports and Crashlytics. A lot of my clients right now are actually happy with server-driven UI. They kind of control the homepage, and I don't have to even blink an eye, and I can get the Play Store updates for other features which are not server, or rather UI-driven, right? Very simple concept, try do not repeat yourself. So I want to minimize the execution time for the front end for not working on UI. I would rather build a team where they could focus on the right things and the right business logic. There's a lot more that we could do on architecture, testing, and whatnot. But a lot of people would be focusing on the UI, making it fancy and animations and whatnot. What if some of the components can be pre-used, or rather, sorry, pre-built and then reused, correct? The most important thing that I'm trying to propose here is that it should be easy to maintain. It should not be something that you've just written out of the box. There's a dedicated team. If you're in a large organization where there are 5 people just working on this, but then they're not building the features, actually. They're just maintaining the library for you. So it should be easy to maintain, but any engineer on any team can just come and plug and play, right? So let's kind of break it down to what it actually boils to. So we have a state, obviously very simple. We are taking state as a data source. That is, whatever the server wants to control, or whatever the server is trying to say, that data is now represented as state for me in Android app. We then take it to a rendering engine, which could be a view model or an engine. These words are not symbolic to the architecture components that we are all familiar with, but just think of an engine which takes an input and then spits out some UI components, right? Depending on what the layer of that data is. We then build some components. It's a common library. Then this can react and have polymorphism all over it, right? So it could be a simple text view which could take a heading style, or it could be a body type. A simple example. We'll be taking some examples in the next slide. So imagine I want to build this kind of a screen, and this is a very, very basic example. I did this with an Epoxy library, one of the libraries out there. What I wanted to do was like put some 3-4 cards, have a button, checkbox, radio buttons, standard stuff, right? And I didn't write this on XML. This is all controlled through a JSON, which I'll anyway explain in a few seconds. What I'm trying to show you here is that red box that's highlighted is what is doing the rendering for you. So a state tells that this is what my reaction should be, and the UI then reacts, and that's where the events are then triggered. If I click the button, click me, there's an event that then triggers another state, and then maybe the button can become a loading bar, or it could change color, or it could hide, or whatever else you have, right? Now, there's also components. How I'm dividing the components are these individual things. You can also call the text view, like my name over there on the top, could be a component, but I've decided that the first card, the second card, all these are like components, pre-built for like various purposes. It could be very business specific. It could be also very generic. You could reuse these things in any app that you want, and then you can push your data from a network layer and then react based on that. Now, there's also the equation that I mentioned before. The UI is a function of state. You can also kind of say that in every almost like, okay, let's call it like 9 out of 10 developers here would be working with JSON. A lot of people are on protocol buffers. There are different bullets to solving the same problem. But if I take a very standard practice, state is JSON, right? Someone is providing me the JSON. It could be simple key value pairs coming from your shared preferences, your data store, whatever we currently use. But it's still kind of like symbolic of the fact that there's some JSON, and I want to take that and then convert it into a state. You can also say JSON comes from backend, right? So in reality, I'm changing the equation. I'm going to say UI is a function of backend. That's what the concept is all about. Now, this is just a very plain and simple idea of what we're trying to achieve here. I want to draw UI based on what the backend tells me. And instead of doing it through data-only kind of APIs, I am also getting some meta, which tells me how the component should be positioned, how should it react, and what is the state, and so forth. Now, there are some libraries out there. There's Litho, Epoxy, Proteus, and so many more. Obviously, JetPack Compose too. We'll be focusing on two things today, the Epoxy and the JetPack Compose. There's a lot of code to run through. So what I'm going to do is I'm just going to quickly jump into Epoxy. It's, again, a very popular library, kind of, I won't say deprecated, but then, yeah, the support is almost dead for it, but it's pretty powerful. I've been using it for about 2.5 years on production. Now, the concept is very, very simple here. Again, you have a UI component library on the right side. We have some containers. When I say containers, think of a shipping dockyard, right? You have a lot of those small things that you want to ship, maybe your Amazon order. You get it in a box. That is what a container is. Now, there's also a view component, which is basically those checkboxes, the buttons, and all the basic components of your UI toolkit. You're taking each of them and you're creating a network layer then which can pass some inputs, then the UI component can react. So that is what the UI component as a tree structure looks like on the right side. The response is very simple. It's a backend-driven thing, which then is converted into a data. And then that data is maybe a data object, and then that could be passed on to your UI component. Now, the concept is very unique here. It's components-driven UI. So when I say the statement, it means that I have some components, and the UI can be driven by just reusing some of those components in different shapes and sizes. The idea is that you don't have to reinvent the wheel. You're reusing some of the components that are already pre-built, and then you're putting some different state to react based on that state. So how does Epoxy work? If you remember from the first diagram that I did, there was a red box around the entire page. That is what the red region is. That's where the configuration data is going to say, hey, this is the screen. I'm drawing a container first. And that's where the yellow part comes. Epoxy is based on recycler view. So it's not new concept. It's just putting, instead of you building different view types and writing the get view item by ID, you already get control from an adapter that sets up everything for you. And those components are then, you can write extensions on top. Now, what those blue boxes are on the last layer or the topmost layer are those components that we have already built. So I'll be taking some examples. Like, for example, I just want to build a simple checkbox for that text view, correct, or the component there. Now, how would I represent this in data layer? It's a pretty straightforward thought process. We have some states. You obviously have a checkbox which is enabled, selected. By default, the server says, no, it's not selected. Maybe a terms and conditions page. And I want to show some text. And I'm basically doing something called a discriminator pattern. Now, what that view type at the last is, it's saying that it's something called checkbox. It could be a key value mapping. All you're doing is you're discriminating from all the entire JSON. Just imagine this as a JSON script, right? There are other JSON elements in a JSON array. When the discriminator comes, I have already identified view type is equal to checkbox. I have a mapping, which then converts it to that respective component, and then based on what the other properties are, and then take it from there, right? So just coming back to the original example, if I have to build this from scratch, how would I go about it? Let's look at it from a top-to-down approach, right? The first thing I'm going to be doing is obviously taking an ID because, well, Epoxy works on a concept of you having stable IDs. If you're familiar with Recycler View, there are a lot of APIs around how IDs work, but then Epoxy uses that to its advantage by saying ID is what I'm going to do for doing the diff for you. So if a component changes as a state, even if the first text changes from Adit Lal to say Lal Adit or something like that, that data will only be reflected on the UI. Nothing else will flicker, nothing else will change, and that's how the control factor is. If you realize so far, I've not even spoken about how Epoxy library works, but the concept is pretty much the same for, let's say, Compose or Epoxy here. Now, what we're doing here is we have some parameters called children, and then there's a view type. I've also declared another discriminator called view group. View group is what is going to then drive, oh, OK, this is the layer. This is where I'm going to draw all the components. The white screen without the card is where the view group is going to be. If you realize there is a view group called card here, what I'm trying to do is I'm building that card section over there. So just by putting this two parameters, I'm drawing that little gray box there, just for illustration purposes. Next, I want to do a small image view, right? So I'm going to have the children now inflated up. Inside the children, I'm going to be saying something like another discriminator. Sorry if the text is a bit unreadable for you guys. Circular image is another discriminator, and I'm passing a URL. I don't have to do anything else. I'm not going to say what the cache is, how to fetch that image URL, what are the key tokens, none of that. The idea is that the UI component can react based on that state. The state is this is the URL. If the URL changes, let's say someone changes their avatar photo, that URL changes, only that component should react when the state updates. Now, similarly, I have another children, which is another view group. Linear is just an example. It could be linear layout, relative. You can build a lot more things with just using those components together. What I've done here is I put two text views. Again, there's a view type called text, and then there's another thing called, I have another thing called engineer and my name. Now, these are two text. I've not said anything about how the position is. It's just the way linear works. By default, I can have a linear vertical, linear horizontal, right? This is just for brevity. I've just kept it very plain and simple. Now, this will place it in this order. What we get at the end of the day is that card with those three components, the image view, the circular image view, and the two texts kind of aligned up. Now, the JSON looks very straightforward. It's nothing complicated. But as you start introducing more complex problems, like how do you do positions and how do we do reactions to, say, clicks and events, the more complexity arises from there. Again, just another example. I have done the second card just by placing a view group card and then obviously have some children around it. Very similarly, I have an icon. This is another. If you realize I said something earlier, right? There's a component library. This is where you are actually working the meat of the entire thing, right? This is where the components are coming out of. Someone will react to this and then call the corresponding component and it'll be drawn, right? Now, I also have a text view. That's what is getting drawn there. So just to kind of explain how Epoxy works, even though this library is pretty old, and it's also like, it's not one of the most, like the latest tech, but then definitely worth checking out if you're just in the market to do something quick and you want to try prototyping. So the idea is very straightforward. We have a state that comes into an epoxy model. Epoxy model is your data layer. It then gets connected to a view. If view wants to react to something, then there is obviously, it's a very unidirectional process. So that means the view can say something has changed. It can update the state. The state will then convert itself into an epoxy model, and then again, the view will get refreshed. So we have no, bidirectional process, so that kind of eliminates a lot of the bottlenecks that most of the bidirectional frameworks have. Now, very simply, I'm just written a small statement that epoxy is equal to view model. I'll come to what that means once we look at a code. But just reiterating, we have an item or a data class or some kind of a component in a JSON array. We're taking that item, converting it into epoxy model, and that is now responsible to draw that layout resource. So think of that text views, the checkboxes, the cards that we had. You can even make a complex example out of it. I'm just taking simple basic components. You can make more complex examples and convert it into a layout resource, right? Now, coming to the actual code. Now, I've written a very simple interface, which is base component data. This is what is representing how my network layer will get interfaced back into the app. What I have here is that base class, which is just giving me an ID. I want ID so that it can be uniquely identified. This is the component I'm touching, right? Think of it like all the layers of, or all the components that you have it in within the vertical list are all components, right? Now, component data is another interface which anyone can extend. I can write a checkbox component data. I can have a complete assistant card, the purple card that we saw. That could be one component. It's up to you how you want to design your business logic around for these components. Now, all of this is very straightforward. I've also given some extra components now, width, height, where is the padding. Like all these things are like positional data that I want to capture. Network can tell me this, and based on that, I can then take some subjective, question marks of how to place it all together, right? We'll take a look at all that next. So again, just reiterating, I want to bring the concept of discriminator. I have a view type is equal to text. What is the text state? It's hello world. What is the ID? There's some ID for that. And there's some height and width. Based on some enum constants, or it could have a seal class or whatever. Based on that, it'll draw it on a particular view group. If you have done any XML designs before, you put a linear layout, you put a text inside. Or if you don't put a linear layout, you could have a frame layout, position things. Very similar concepts of placing the components together. You could also have something called gravity, just in case you want to linearly change how the position of that child is, correct? Now, if I take an example of the text component data, all I'm doing is the data class. It's obviously passable, so I can pass around the components. I extend the component data, I give the overridden methods, and I say there is an extra payload too, in case I want something like this. So if you have a parseable that you want to pass, like if you have dependency that if this button is clicked, there should be some reaction on this text view, so you could have some parsables there. The padding, the view type, all of this is like pretty much confined to that interface that we had before. Now, coming to the epoxy part of things, right? This is where the fun starts. So we have an abstract class. Obviously, epoxy works on annotation, and then it auto-generates a lot of code for you. What it does here is that if you see this particular thing, what I've done is it follows the same view holder pattern of a recycler view. Again, it's based out of a recycler view. It takes a text component and says, this is my view holder. This is what the view holder will look like. It's very similar to you defining your recycler view adapters. At the top, what I've done is I've given the layout. So this layout is what is going to give me a simple text in which I can throw any text I want. And I can put a style. I can move it around and so forth. How does it all look? We have a view holder pattern, obviously, which then has a binding. You can control this binding by adding some more meta around this. This is just for brevity that I have condensed the code. But the simple concept is if you have let's say the data, how do you pass that data? So it's a unidirectional flow. As I mentioned before, you are taking an item or a JSON, converting into epoxy model, taking it next to the layout resource. So this epoxy attribute is one of those things where you pass your text component data. Remember the data class we just saw? That data is passed in as an epoxy attribute. If that data changes, which now Compose does it beautifully, the states and all that in Compose. Prior to that, epoxy had this thing called epoxy attribute. During compile, it would say, hey, this is the mapping. If someone changes the ID, the hash of that, it will automatically say this view holder has to be refreshed. And that's where the diffutal of epoxy plays very well for you. So the whole code looks something like this, just moving ahead. Now, all of this put together, you need a controller of sorts, right? Now, there's a concept called controllers. I'm using something called a typed epoxy controller. It's basically a when clause amplified for all the purposes that you have. It's basically all the view types, all the component library, components from your component library would be useful for you. All I'm doing here is just saying when the data comes, it could be a JSON struct. In that struct, check what are the discriminators. So this is where the mapping happens. So you see that generate model code, that's where this guy comes into picture. Oh, sorry, yeah. Before we jump into that, there's also an overridden method, build models. This could be re-triggered if you want, if a state changes, not directly. So if a view cannot say that this controller should do some reaction, it is, the view can actually go and update the state, and then the state will automatically trigger this build models. And wherever the ID has changed, those components would be then redrawn. So we have this concept called build models. What I'm doing here is like, inside that I have a function called generate model. You might be noticing something called add to. This is not an Rx Java code. It's just a simple thing that there's a container, right? There's a recycler view. This component should be now added once it is processed. So that epoxy model is converted into its corresponding layout. That layout should now be rendered at this position. So if you have, ordered data, that data can now be drawn in this fashion. What I'm doing here is I obviously have some click handlers. I have some, if the component doesn't exist, versioning basically, like if I have text views, checkboxes, all the basic components, but now server started sending, hey, draw the assistant card, the purple card. I don't have support in, say, version 5. But in version 6 of the app, I have it. So that uncaught handle reception could be analytics or whatever else you have. So there's a lot of plug and plays. It's a very involved code that way. Just to kind of reiterate, generate model does all this and then adds it back to the parent recycler view that we have as a view group here. Now that concept of add to can also be conditional. You don't have to just automatically add. You can also put it if a person is logged in, only show this component, otherwise don't show it. Instead of even server controlling every bit of your UI, you can still have some control factors. Now, how does that generate model as a function look? It's pretty simple. We have that base component interface, obviously abstract, so we can pass in any type of data, which extends that. Now, what I'm doing with that is taking, sort of like a mapping function. It takes into the data, decides what type it is. There's auto-generated code, which looks like this. So we had a component class called text, right? Text component. There's an auto-generated class, and then there are these methods called, if you remember, we did something called epoxy attribute. Now that attribute is a function that is auto-generated for you. You can pass your data in. You can also avoid sending it in, but it's also advised not to do null, null data over there. Now, obviously I have a component click handler. What this does is, obviously just a simple lambda from Kotlin that is then passed into the text component. So whenever this guy is clicked, you can react to it based on the ID and so forth. Very simple concept. So the two things that we have done here is like we have added epoxy attribute. I'll come back to the actual text component. Sorry, yeah. So what we have done here is we have a late init. Obviously, we have the data class epoxy attribute, and then we have the component click handler. You can react to this view holder. The view holder can react to these two things based on whether this is re-triggered or not. So that function from the controller, typed epoxy controller, could trigger the build models. Depending on which diff is supposed to be triggered, it will call this particular class again and say, hey, this is what has changed. Please redraw yourself. And that's the power of epoxy. Now, we're taking advantage of all those things, but obviously have the view holder pattern, so this concept should not be very difficult to kind of grasp. What we're doing here is, again, this is not an epoxy thing, this is just my way of writing some custom views so that I can control, instead of reinventing the wheel every time, I have just built a simple screen list view class, which is just a frame layout in which I've added the epoxy recycler view. Instead of adding a recycler view, I've just added an epoxy recycler view, given it the attribute set, all the context and whatnot. And this is where the actual magic occurs. So this is the layer to which you can actually inflate this as an XML component, and you can then throw in your other click handlers, maybe uncaught, and all those things, right? Now, those controllers that we saw before, that's again reused. Again, I'm doing a lazy over here, just for the benefit that maybe the data is not ready. Do not inflate anything, right? And also the layout manager, all the recycle view components are still the same. There's a binding. I'm using view binding here just to control that. There's a small resource file that has this epoxy recycler view to which I'm adding a controller. Like you do adapter to your recycler view, all that put together, then this comes to life, okay? Very simply, in the same class, I have the e-recycler view with the notation of ERV over there. I'm giving it a layout manager, and I'm setting the controller. That's how the epoxy APIs work. And then I take that and say, hey, if there are components that you want to set up, you can also have dynamic components. You could call this function called setup components, which is the list of all those components, text component, checkboxes, and whatnot. Some screens may not need the entire component history or all the components in your library. You could have that initialized based on what you want to register. Only components that are registered and only controllers, only knowledge to the controller of the components that you have would be then rendered for you. If you have, say, something like a checkbox put into your controller for this screen, this will be reused for that particular component, okay? So the click handler, again, just a lambda, you can, I've just done a type alias over there so that it's convenient for reading. Now, coming to the fun bits, we have a network layer, obviously. I've taken a very simple example of JSON. Again, this is just more of a proof of concept, like how do we take it further? So we have a runtime library. We have Moshi and so many other libraries that have runtime capability, all polymorphic data. We take this data, and then we say, hey, there are these view types, the discriminator. If this key comes into the JSON, please interface with this and then extract out what the entire JSON object is. Based on this, I can then start registering subtypes. Just for the sake of it, I've just done one, but you could have like hundreds of these or maybe a few more, depending on how your use case is. And then when you're building a JSON during your Dagger initialization or wherever you have your application code, the platform stuff, you could actually register this runtime library or an adapter factory and then pass along how to handle, say, some use cases around, say, Kotlin generics and stuff. Okay? Now, this is the fun bits of Compose, but let's get to, of Epoxy. Let's quickly get into Compose, right? Very similarly, UI as a function, Kotlin is still pretty useful. It's a declarative UI. So the concept of declaration is, I don't have to do that width and height and all that gravity and all that other crap, right? I can actually say to Compose, hey, you figure out the mathematics of how to place it all together. I'll give you the relational state of how I want to draw that data. Very similarly, to Epoxy, we also have the Compose UI. The red container is where the actual screen content is drawn. The yellow is the actual base of how the theme would be set up and how the, the localization, compositions, and all those things will be rendered. And then there are these Compose views. They're not equivalent to the XML views. I'm just putting those names as Compose view because, again, these are components that I'm talking about. It's a concept of having, uniqueness. So if I take this example of a simple model in India, we have something called Swiggy, which is a food delivery app, DoorDash kind of equivalent. If you notice, this homepage is like very dynamic. I want to control how the banner images changes, what are the top categories. In my area, let's say I order a lot of Korean food and I want to change that up, the top categories. What if I don't want to do this through, pushing home activity 1, home activity version 2, 3, 4, and 10 million other variations of it. What if I can break down this into components? And the idea here is, as you can see on the right side, we have a lot of those boxes, fun little components that I want to build. If I quickly run through this, it's something like this. We have show banner element. We have, sorry, I'm just quickly running through this due to time factor. We have container. If you're familiar with Compose code, we are drawing some components together. I'm saying there's a clip shape. I'm drawing some image, just custom Compose functions, nothing fancy, just another glide inside. All I'm doing here is like I'm giving those components a definition or a kind of, let's call it like a sketch that this is how it should look. If I quickly skip through, this is how the component should look like. So this is just a cute puppy there, but the concept is same, right? You want to show some items right on the top. You could do something like this in Compose. Now, what I want to kind of quickly jump into is the concept of hoisting. In Compose, we have this principle, which is a state should not be part of the Compose function itself. It should be outside it. So that is what's called hoisting. So someone else controls the state. The Compose function that you're trying to draw becomes stateless, and that's where the control factor comes. So what I've done here is I've done the hoist. I have some states that I'm going to be managing, and the previous function call or the upper stack call side would then control how the state is pushed downstream. So in Compose, you can also do servant-driven UI. The code should be very straightforward. Again, the same function is just moved into a class, which is now overriding that the composable element as an interface. And then there is that hoist method, which can then be given the control. You can also pass some mutable types of data sets, or you can even make it immutable, sorry, for that matter. What I'm doing here is like the last line is the most important. I'm giving it a field name, that mapping of sorts, that this function should be triggered when this particular view type comes. That is where the control factor is. Quickly jumping through this, again, I have a very simple enum class, view type. I have a banner, text, and promo. When I actually convert this, I want this banner to be rendered in this state. So that compose function is that invocation, or the Kotlin invoke operator. That's what's going to get invoked there, because it's @composable. And this fellow will then be responsible for mapping everything for you. And DTO, very straightforward. I have all the children of a particular screen that I want to draw, and I want to then generate each element, or every single row of the screen with certain metas. So there's a default, there's data, some parameters that I could extend. Quickly skipping through this, nothing fancy. Empty element is just another way to, if you want to draw a white space, you don't want to do anything. If the particular data type is not registered, you want to control that, you can have a very simple map off and nothing will be rendered. How does the root screen look? Again, following the custom view kind of a class. I have a screen class which takes in the screen data. Think of it as your JSON class. All the elements are broken down and then pushed into a composable function. And depending on what the type is, the mapping function will handle everything for you. Elements.zip, it'll take all the components, see that particular view type as a discriminator, and then call the compose function for you. I'm using a pair object so that I can say which view type is responsible for which compose function. Okay? Sorry, I'm just going to quickly skip through this. The main activity should be very straightforward. I have a view model, I have a compose theme, and then all this just puts together. This is where the data class is. This is the string holder. I've just taken a very simple string holder. I have not done any fancy things like network layer. I'm taking the string holder as a JSON state, taking that and putting it into the next layer, which is called ambient off. Ambient off, again, I'll leave it as an exercise for you guys. It's a JetPack Compose API, very, very powerful. You should definitely check it out. Now, what this does is it takes that screen JSON. Sorry, if I'm walking through, Moshi builds it for you. We, again, have a polymorphic adopter for you. It then provides all those polymorphic bindings or the mappings and then controls the JSON component. And the last best part of all of this is the last thing. Sorry, if I can quickly focus there, yeah. Oh, sorry. Screen, you give it the data type, and then you call the compose function. So invocations can happen even from a non-composable function. So the idea is that because this is all written inside a compose function, this my screen content, it could be the content component that you can then draw inside your screen, and screen could be then inflated in a compose theme, and that's more or less what we're trying to achieve. Something like this. So the USP of all of this is that the fact that you can control some mapping function that can then draw some components. One advantage of all of this is you can have an in-house design system. If you have a team who can build it, great. If you realize the goal was it should be easy to understand, it should be easy to maintain, and it should be reusable. So all of this put together then comes together like this. This is a dynamic screen now. Server can configure it. You can pass in your server JSON, and that's about it, right? Quickly just scrolling through. Again, I have a lot of content on this slide. Sorry about that. Just want to quickly show you how things would be. You could have a discriminator like this. If it is a vertical list or a banner of certain elements, you can have that defined like this. You could have individual items then just scan through, depending on what type of data it is. As you can see, it's a type of restaurant, so I'm going to show a restaurant composable function. That's where the invocation occurs. If it is not, if it is some kind of other element, then that's how things will all fall together, right? And then set content could then call your view model on top, and everything comes together. With that, I have a lot of code to be shown today, but then thank you so much. But we have some references if you want to take a shot of this. There are a lot of good articles out there, a lot of videos out there too. You can also check out Beagle and Epoxy, but my preferred way of doing things is now Compose. I probably would not even remember how to write Recycle View anymore. I also have a very small plug-and-play kind of thing. I have an open-source design system library on Compose. You can actually take a look at how I brought the thought process back into that library and have actually made it open source. There's also a demo app that you could go and take a look. With that, that's all, folks. Thank you for staying for 4 extra minutes. If you have any questions, I'll be happy to answer.